Welcome, my name is Christiane Garabeles, and today we will be talking about contact angle measurement. So, contact angle is a quantitative measure of the wetting of a solid by a liquid. Contact angle is defined geometrically as the angle formed by a liquid at the three-phase boundary where a liquid, gas, and solid intersect. The instrument of choice to measure contact angles and dynamic contact angle is an optical tensiometer. A force tensiometer can also be used. Both optical and force tensiometer enable static and dynamic contact angle measurement. Like as we can see the figure below, it can be seen that the low contact angle values indicated that the liquid spreads on the surface while high contact angle values shows poor spreading. So there are two ways how to measure contact angle. Both optical and force tensiometry can be used to measure contact angle. Both techniques are described below with comments on the choice of either technique for particular application. So the first one is the optical tensiometry. Both static and dynamic contact angles can be measured by using theta optical tensiometer. Dynamic contact angles can be measured by using two different approaches, changing the volume of the droplet or by using tilting cradle. So in practice, a droplet is placed on the solid surface and the image of the drop is recorded. Static contact angle is then defined by fitting Young-Laplace equation around the droplet, although other fitting methods such as circle and polynomial can also be used. So the figure below shows the principle of the volume changing method. In short, a small droplet is first formed and placed on the surface. The needle is then brought close to the surface and the volume of the droplet is gradually increased while recording at the same time. This will give the advancing contact angle. The receding angle is measured the same way, but this time the volume of the droplet is gradually decreased. So, the part B, the principle of the tilting cradle method is shown. The droplet is placed on the substrate which is then gradually tilted. The advancing angle is measured at the front of the droplet just before the droplet starts to move. The receding contact angle is measured at the back of the droplet at the same time point. So these are the following are the advantages of optical tensiometry. Optical tensiometry is the best choice when liquid-solid interaction and or solid properties are measured in samples that are not homogeneous and regular in size and in shape. So the main benefits are the following. Small liquid volume demanded, solid substrate can be asymmetrical, both sides of the sample don't need to be similar, contact angle mapping over the surface enables heterogeneity and cleanliness characterization. And lastly, the roughness correction possible. For the next slide, we will tackle about force tensiometry. Dynamic contact angles can be measured by using sigma force tensiometer. So force tensiometer measures the mass affecting to the balance when a sample of a solid is brought in contact with a test liquid. The contact angle can then be calculated by using the equation below when the surface tension of the liquid and the perimeter of the sample are known. In the figure below, a complete contact angle measurement cycle is presented. As can be seen, with force tensiometer, the measurement contact angle is always dynamic contact angle since the sample is moving against the liquid. So when the sample is immersed to the liquid, the advancing contact angle is recorded, and when the sample is emerging, the receding contact angle is measured. The sample is above the liquid and the force length is zeroed. So you can see the stage 2, wherein the sample hits the surface. For the sample as shown with the contact angle less than 90 degrees, the liquid rises up causing a positive force. Part 3, which is the stage 3, the sample is immersed and buoyant force increases, causing a decrease in force on the balance. Force are measured for advancing angle, and for the last stage, After having reached the desired depth of the sample is pulled out of the liquid, forces are measured for receding angle. The advantage Next is for the advantage of force tensiometry. The force tensiometry is an excellent choice when dynamic contact angles on the homogeneous regularly shaped samples need to be measured. Analysis of single fibers such as wetting of hair is handled easily by our sensitive force tensiometer. In addition, force tensiometer is the best choice when loose powder or pigment wetting properties are measured. And the last slides we can see is the references. And that's all. Thank you.